Section 3.3, Synthetic Division and Solving Polynomial Equations. In this first video, we are going to learn how to do synthetic division. So we will start by reviewing the vocabulary that goes along with a division problem. So you see here on this slide, if you just had a normal division problem, then the first part of it would be called the dividend, and whatever you're dividing by is called the divisor. The answer is called the quotient. So a long time ago, you learned how to do 26 divided by 5 with long division. So let's just review that real quick. So the 26 would go inside the little house, and the 5 would go outside. And I would first look to see how many times 5 will go into 2, and it won't. So then I go into 26. 5 will go into 26 5 times. So we put that up here. Then we multiply 5 times 5. Write that below and subtract. The number that we get here at the bottom is called the remainder. Sometimes the remainder is 0, but not always. So if the remainder is not 0, there are a few different ways that you can write your answer. But one of the ways is to take that remainder and put it over your divisor. So we could say the answer to this problem is 5 1/5. So you take the remainder and you write it over the divisor. And that is actually how we are going to write our answers when we do synthetic division. We're going to have our quotient. Now, we will actually have a symbol in between, whereas when we wrote 5 1/5, we did not. So you will have either an addition or a subtraction, and then you will write the remainder over the divisor. Unless the remainder is 0, and then you won't even need that fraction on your answer. Okay, so synthetic division. This is a special method that is only used to divide a polynomial by some binomial that is in this form, x minus c. So the first term is x, and then you have to have a constant. If you had, say, like a 2x plus 1, you could not use synthetic division because of the 2. If you had an x squared minus 3, you could not use it because of the x squared. But if I had x minus 5, I could use it. If I had x plus 2, I can use it. So that's when synthetic division works. It doesn't work for these. It does work for these. Okay. So I am just going to teach you the method by working through some examples. So remember, the first polynomial here in our problem is called the dividend, and the second one is called the divisor. So you are going to look at your divisor, and notice it said x minus c. It had a minus sign in it on the previous slide. Then when we look at this, x minus c, c is positive 2 because of the minus sign coming from the formula. Okay. Another way to think about it is if I set x minus 2 equal to 0 and solved it, I would get x equals 2. So we need to write down the number 2. Okay. And probably the easiest way for you to remember that, I'm going to put an arrow here, is this number that you write is the opposite sign of that number, that constant that is in the divisor. Now we're going to do kind of a different symbol than we do for long division. We are going to put a half square around that 2. Okay, so a line on the right and a line below. Now out to the right of the 2, we are going to put the coefficients of the dividend, and those keep the exact same signs. So we would put the positive 5, leave some space, negative 6 coming from here from our x squared, positive 3, and positive 11. So those are the coefficients from the dividend. Okay? Exact same signs that you see in your dividend. Now you're going to leave a space underneath those numbers because we're going to write underneath them and then draw a line across. And the way you start the process is this first number that's to the right of your little half square is just going to drop down below the line. Every time, that's how you start it. You drop that first number below the line. Now, that number is going to, let's change colors here. That number is going to multiply by the number in the square. Multiply. So if we do that, 5 times 2, we get 10. And we're going to write that 10 below the next number in our problem. So we're going to write the 10 here. Okay, now you've got two numbers in a column there. You are going to add. So this row and this row, you add the numbers together. So let's see what we get. Negative 6 plus 10 is 4. And now we just continue with that process until we get to the end. So we go back to multiply. 4 times 2, always times the number that's in the square. So 4 times 2 is 8. We write that in the next spot. And then we add 3 plus 8. And then we repeat again. Now multiply. 11 times 2 is 22. And then we add 33. The number that we get at the end of the problem right here, that number is the remainder. Always, when you work synthetic division, the very last number below the line is the remainder. Okay, now let's talk about how we write the answer. Look at the original problem. We had a polynomial divided by a polynomial. Then the answer is going to be a polynomial. These are going to be the coefficients, these numbers below the line, 5, 4, and 11. Now, to determine which exponent to put on x, you would think about, well, my dividend had x cubed. Its highest exponent was a 3. If I took x cubed and divided it by x, so x cubed divided by x, that would make an x squared. So my answer is going to need to start with x squared. And it's going to have this 5 in front of it. So we're going to write 5x squared. And then the exponent always goes down by 1 for each term. So if it's x squared to start with, then it goes to x and then the constant. So it would be, this is a positive 4, so plus 4x plus the constant plus the remainder over the divisor. The divisor was x minus 2. And then that is how we write the final answer. And let's make a note here that we knew to start with the 2 because we always start with the exponent that's 1 less than the dividend, okay? The degree, we say the degree of this polynomial is 2. The degree of this is 3. So we want the degree to be 1 less than dividend. So I know we kind of wrote all over this and it's kind of messy. We'll make the next one a little neater. But let's go back through this one more time. So we look at our divisor at the constant and we take the opposite sign of that and we write it down with a half square around it. To the right, we write down the coefficients of the dividend exactly as they are, same signs. Okay. We drop down the first number below the line and we multiply it by the number in the square. We write the result below the next number. and then we add those numbers together. Then we repeat the process. We multiply by the number in the square, write it in the next spot, add, and keep doing that until we get to the end, and that last number is our remainder. When we write the answer, we start with the exponent that is 1 less than the highest exponent in our dividend. The degree is 1 less than the dividend, and we put our remainder over our divisor. So that was a very basic example. There are a couple of things you have to keep in mind as you are doing synthetic division. The first one here says the dividend and divisor must be in descending order. Descending order means highest to lowest exponent. So if the problem is not given that way, then you will be required to do that before you start your synthetic division. And the second note here says, fill in zeros for missing terms from the highest exponent down to 0. And I will show you what that means. So in this problem, we have a fraction bar instead of the little division symbol, but it works the same way. The top is your dividend and the bottom is your divisor. And if you prefer to rewrite it with the little line and dots, you can. So let's look at our dividend. It is not in descending order. X to the 4th is our highest, so let's rewrite this problem. And we're going to put x to the 4th first. Then here we have a cube, an x cubed, so it's a minus 6x cubed. We have a positive x squared and a minus 6x. Now, let's look at our exponents. They are 4, 3, 2, invisible 1, but there is no 0 exponent. There's no constant, in other words. And there has to be for a synthetic division to work. So highest exponent down to 0, then I need to go ahead and fill in a 0 for my constant. If it had not had an x cubed term in it, it had an x to the 4th and an x squared, then I would have to put a 0x cubed in there. That's what that second note means. You have to have a term for every exponent, highest that's in the problem, down to 0. All right, we'll just put it like this. This divided by, now our divisor also needs to rearrange the x first and then the plus 6. And now we're ready to do the synthetic division. Okay, so we're looking at our divisor. We are taking the opposite sign. So we're taking a negative 6, putting that in our square. Now we're looking at our dividend coefficients. We've got a positive 1, a negative 6, a positive 1, a negative 6, and a 0. Without the 0, it's not going to work correctly. You've got to put the 0, leave a space, and draw the line across. Start the process by dropping this first number down below the line. Then we're going to multiply that number times the number in the square. So 1 times negative 6 is negative 6. And we add those together. Negative plus negative is going to make that a negative 12. Now it's negative 12 times negative 6 is a positive 72. And we add those together, makes 73. And sometimes the numbers do get kind of big. You can use a calculator if you need to. 73 times negative 6 is negative 444. So now we add. We have the same signs, so we're going to add and keep the sign. I'm sorry, I wrote the wrong number there. I was getting ahead of myself. This number is negative 438. 73 times negative 6, negative 438. And now we add those together is negative 444. And that number back times negative 6 gives us 2,664 plus the 0 is still 2,664. Okay, so we have finished the calculations there. And now we need to write down the answer. So I'm going to change colors. Look at your dividend. It started with x to the 4th. It was degree 4. That means my answer for the division has to be degree 3, 1 less than this. And my first coefficient is a 1, which I don't need to write, so I'm just going to put x cubed. Now, I need to write the next number there, minus 12, and I drop down my exponent to x squared. Then I write my next number. It's positive 73, and then I go to x. So I've got x cubed, x squared, x, and then I write down the next number, and that's my constant. Okay, so my exponents are 3, 2, 1, 0, plus the remainder over the divisor. And that is our answer to the division. Sometimes the remainder may be negative. If this had been a negative 2,664, you can still put the addition and just stick the negative sign up there on the top. Or you could, instead of putting addition here, put the minus sign out in front of your fraction. So you can either stick it on the top plus a negative, or you can just put a minus sign here. Okay, let's go ahead and try one more. Make sure we get the hang of it. Okay, so first thing we're going to check is the dividend in descending order. So look at your exponents. X cubed, 3 is the highest. Then we have an x, and then we have a constant. It is descending, and so is the divisor, x and then constant. However, when you're looking at your exponents in your dividend, you should notice that it's missing an x squared. Okay, I'm going to write that down here. Missing x squared. It's got x cubed and it's got x, but it doesn't have an x squared. So it really needs to become 5x cubed plus 0x squared plus 6x plus 8 divided by x plus 2. And you don't necessarily have to rewrite the whole problem. You could just come up here if you want and put a little caret and say, okay, I need to add a 0x squared in there. And that would be acceptable. Just make sure that you get it in there. If you want to rewrite it, great. If you want to just kind of add it up in there, that's okay too. Okay, now we're ready for our synthetic division. So we look at our divisor. We've got positive 2, so we're going to write down negative 2 in our square. Then we look at our dividend. Take those exact coefficients, 5, 0, 6, and 8. Leave a good amount of space between them and a space below them. Draw a line and bring the first number down. Multiply 5 times the negative 2 in the square makes negative 10. Add 0 plus negative 10 is negative 10. Multiply negative 10 times negative 2 is positive 20. Plus 6 makes 26. 26 times negative 2 is negative 52. Now here we have different signs, so we subtract and take the sign of the larger, results in a negative 44. Okay, so the answer. My original dividend had a degree of 3. So I need to have degree 2 in my answer. So I look at my first number, I write it down, and then I'm going to start with an x squared, 1 degree less than the dividend. Then I write down my next coefficient, and if this is x squared, this is going to be x, and then this number will be my constant. If I had a 0 here in my last place, I would just leave it like that. I wouldn't have to put plus 0 over x plus 2. But I don't. I have a negative 44. So I can put plus negative 44 over x plus 2. Or I can just put minus 44 over x plus 2. Either way is fine. And that is our answer. Okay, so I'm going to go ahead and stop the video there, and you can practice the synthetic division. I would go ahead and do the homework problems over that before you watch the next video, because in the next video we are still going to be using the synthetic division, and at that point you want to be pretty good at it. So go ahead and practice and then watch the next video.